caught me off by surprise while wearing a microphone and sitting in front of a camera and lights. But anyway, I was reading a paper, which is an integral part of science, reading the literature. So today I thought I would make a video talking about reading the scientific literature, specifically how to read a science paper. How do you read a scientific paper? Unless you're an expert in a given field, you probably don't get your science news and updates from primary literature, assuming you get them at all. You probably read popular science magazine, newspaper articles, social media posts, that weird dude at the bar, or worst of all, some YouTube guy. That's fine either way. None of those methods are an inherently bad way to stay up to date with the advancements of science and what's happening in the field, in any given field, or learn about science in general. That said, there might be multiple reasons why you might want to skip the middleman, so to speak, and just jump straight into the source. For example, the popular science approach sometimes simplifies things too much, and maybe you want to learn more. Popular science articles will touch on the highlights of things, on the big picture stuff, but there are subtleties and nuances that are often lost, and perhaps that's what you're interested in. Another reason is very often headlines and articles are sensationalized or often misleading, and headlines or articles can even sometimes outright lie to you. Yes, as shocking as that sounds, people on the internet lie sometimes. We've learned to live with it. And lastly, there's an educational reason. Maybe you just want to learn more and challenge yourself in an advanced topic. Maybe you took a class on a subject, or you've been reading about something, you've been scouring Wikipedia and whatnot, and you want to test yourself and see how you can apply what you've just learned to understand what is an active area of research. That said, if you've tried to read a paper, chances are that it was not easy, or you understood some parts but struggled to understand others. A lot of jargon, unfamiliar methods, complicated language. Scientists are not usually the best of writers. It depends. I don't want to cast any shades to anyone, but that's perfectly normal. It's actually what every student, every graduate student or research undergraduate student at the beginning of their research careers, that's what they go through as they first start reading. In fact, when I started grad school, one of the first things that I asked, in fact, a lot of grad students do this, is they ask their professors, their advisors, or their peers to send them a bunch of papers to read to get ready for the research. And they do. Often people are polite enough to oblige you, and going through those papers that are supposed to be foundational in whatever field you're interested can take a lot of time, can be quite challenging, even for someone who is supposedly perhaps more advanced in a field than, I guess, what my intended audience with this video is. And that brings me to the topic of this video. My goal, or at least kind of what I wanted to do, was to create a tutorial teaching how to read a scientific paper, journal article, something like that. But the truth is, I can't really do that, not in any, satisfying way that I can say I did that. Not really. I can maybe give you a few short tips, but ultimately there is no magic trick. There is no silver bullet that will make you instantly better at reading the scientific literature. In fact, the only surefire way to get better at reading the scientific literature is the same way that every grad student does it, and that is by just doing it, by just reading more paper. The more you read, the better you get at it. And if that's something that you're interested in doing, that's something, if you're interested in getting your science updates, whatever, if you're, for whatever reason that I already mentioned, you're interested in reading more papers, the best way to get better at it is to just simply start doing it. And like I said, it will take you more time at first, and then you'll get better and better at it. Still, maybe there is something I can do, and in my opinion, the best thing that I can do for this from a pedagogical point of view is to actually go through the process of reading a scientific article, especially one from a field that is far from my own, one that I'm not an expert in, and show the process that I would go through to read such an article, teaching by example, so to speak. So let's get to it.
Okay, so I have to pick a paper to read for this video, and it has to be something that I'm unfamiliar with, but for the sake of intelligibility, something that is not so obscured or complicated for a short YouTube video. Let's see. Okay, this one looks pretty good. Acetaminophen use during pregnancy and children's risk of autism, ADHD, and intellectual disability, published by this group of people in the Journal of American Medical Association. A nice random paper for the purposes of this video. This should meet most of our criteria. I am a physical chemist, so I never really read medical journals. On occasion, I guess, but not really. But this is a nice, fairly accessible topic to read about, at least as far as big picture stuff is concerned. And I know just enough about statistics to be able to stumble through a paper like this. So this should be fine. There are a few things I want to address before jumping into this paper. First, where do you get papers? If you've tried to access a scientific paper before or any kind of journal article and you're not part of some research institution, you may find that they're often behind a paywall. That's annoying, but let's not get into that right now. So if you want to read a paper or papers, where do you get them? Thankfully, more and more newer papers are published as open access, so they're free for everyone. That's great, but obviously that doesn't apply to everything. If you're trying to find a paper that is not open access, try Googling the title. Even though the paper might be behind a paywall or on a publisher's website, it may be available for free in a different format, somewhere else. It may be available as a preprint, that is before it went through peer review, for free. Keep in mind that this might not be the final version of the paper, but it should be close enough that you would at least get the gist of it. It may also be available on the author's website, on the institution's website. Many universities will store papers from their professors, or somewhere else. Some grants require that a free version is available somewhere, usually not formatted, so you may be able to find that one. For example, if we Google this article, the one that I just picked from the Journal of a Medical Association, we find that it is also hosted on PubMed Central. In fact, many biomedical articles are available there for free. As a last resort, you can also try emailing the author or the authors of the article for a free copy. They might ignore you, but generally most researchers are happy to share their work with you as long as you don't spam them every other day for a new paper. The second point I want to make is that if you're a beginner, you should set your expectations accordingly. Whenever you read a paper on a subject you're not an expert in or even familiar with, you're not going to get everything. That's okay. Make peace with that fact. There will be jargon, methods, nuances of the study that you will miss. And again, that's perfectly all right. It requires patience, but you will eventually get there. Lastly, how you read a paper or how much of it you read will depend on your goals and aims. Why are you trying to read it? I already mentioned some reasons, but your specific aims, what you're trying to get out of the paper, will determine how you approach it. Whether you're reading it to get the big picture, to understand the methodology as part of a literature review, just to get the results, etc., will determine how much of it you read and how you approach the reading of the paper. If your aim is accomplished just by reading the abstract, then just read the abstract. You don't have to read the whole paper. So again, the approach will depend very much on what you're trying to get out of it. Okay, so with that out of the way, let's get to reading the paper. Make sure you're comfortable and in a well-lit location. You can wear headphones and listen to music if that helps your concentration. Grab a drink, light a candle, whatever you need to get in the mood of reading some science. Normally, I don't print papers out. I just read them on my computer or tablet or whatever. I just did it for this bit. Actually, this is not even the article in question, just some random pieces of paper I found lying around in my apartment. Of course, as soon as you start staring into that large block of text, you likely get the immediate urge to procrastinate. That's normal. Oftentimes, these papers are really dry and boring, and especially if you're not an expert and you don't particularly have a passion for the field. So you'll be tempted to put the paper down and look at your phone instead. Eventually, though, you're gonna have to put down the phone and get to reading. So first things first, let's start with the abstract. You don't have to read the whole article in order. In fact, most often you don't. But it's not a bad idea to start with the abstract, regardless of what your aims are. So let's do that. The abstract format for this journal is structured a bit different than most. So you usually don't find this much information. It's usually just a shorter summary of the paper. So I'm not going to read every word of the abstract, but the gist of it is they compared children whose mothers had taken acetaminophen during pregnancy with children whose mothers had not taken acetaminophen, with the purpose of determining the association of acetaminophen with certain neurodevelopmental disorders such as autism, ADHD, and intellectual disability. The results suggest that there is an association when you look at the data directly. However, when you adjust for sibling control, there was no association. Similarly, there was no evidence that the dose of acetaminophen matter. This abstract is pretty clear and to the point, and gives a pretty decent summary of the article. It's also fairly accessible, relatively speaking. If all you cared about was to find out what the study was about and what it found, in a general sense, you would not need read any further. There are, however, some questions that the abstract doesn't answer, and if you're interested in those questions, you'd have to read further. For example, the abstract tells you where the data comes from, but you may want to know more about how it was selected, how it was processed, the motivations, etc. You may want to know about the statistical methods and their reliability. Is the methodology sufficiently rigorous to justify the conclusion? They talk about risk difference and hazard ratios in the abstract, which you may or may not know what they are. So to find out more, let's read a little bit further into the paper. Normally, for the papers I usually read, I rarely bother to read the introduction and simply jump straight into the results or discussion section. But since I'm not very familiar with this topic, I think it might be beneficial to read the introduction. This is one of those rare instances where it might just be better to read the paper in order. The introduction for this paper is pretty short, which I usually love. It starts with the motivation of the paper that acetaminophen has been linked with neurodevelopmental disorders by some past studies. Then, the author makes the case that some of this association may be inaccurate or incomplete, bringing up the possibility of confounding variables not taken into account when studying this effect. This is a classic case of correlation does not mean causation, very often because there may be a root cause for both variables that are correlated. The common example given for this is that if you look at the numbers, there is an association between ice cream and drowning, even though obviously ice cream doesn't cause drownings, allegedly, with the common cause of both being that they happen in the summer. Although I don't really know, I eat ice cream year-round, I don't know why everybody wouldn't, but you get the picture. Similarly here, the perceived association between acetaminophen and neurodevelopmental disorders may be due to an underlying cause connected to both, such as migraines or pain from autoimmune disease that could lead to an increased risk of neurodevelopmental disorders that could also make it more likely for the mother to take pain-relieving medication, like acetaminophen. Of course, the authors provide citations for each of these points, and if this is a topic that you're interested to explore further, those citations are a good place to start. Actually, the introductions of papers are a really good resource for this kind of thing, suggestions for further readings on a given topic. The next section is the methods section, where they describe the statistical methods, how they collected the data, etc. Again, depending on your purposes or familiarity with the subject, this is a section that you can skip or briefly glance at. For example, if you're familiar with the statistical methods that they use, after all, these are not invented out of thin air, they tend to be fairly standardized across different studies of similar purpose, you can just skim this section and then immediately say, oh yeah, I know what they're doing here, and jump straight into the results. Of course, the converse can also hold true, where you are familiar with the method and you know their limitations, so you want to check the sections carefully and make sure that they've addressed those limitations in a satisfactory manner. From the abstract, I have a pretty decent idea what the methods they're using here, but since this is an educational video, let's go through the methods section of this paper. First, they describe where their data comes from, when they stopped collecting the data, which is December 2021, and the various cleanups that they did. Pretty standard stuff. Then they specify how acetaminophen use was recorded in the time frame that the study considered, the difference between over-the-counter use and prescription. Their primary metric was if their mother had ever used acetaminophen, but they also considered dosage to a lesser extent, because from the database that they collected this data, that information was available, at least for prescribed acetaminophen rather than the ones that they had taken over the counter. They describe how these neurodevelopmental disorders were diagnosed, and then a really key part of the paper, what covariates or what other factors were considered in the analysis. They go over a long list of covariates that they were able to record for their cohort, such as whether the mother was diagnosed with migraines, fever, chronic pain, sex of the child, and so on. The list is pretty huge. How much you want to focus on any particular item on this list depends on what you're interested in. I will move on. One thing that you'll often notice is reference to supplemental materials in the paper. They often contain extra information such as raw data or further analysis and figure that some people would find useful but may be redundant to include in the main paper. You usually get access to those through the journal's website. Next, we get to one of the most important sections of the paper, and that is the statistical analysis. Right in the first sentence, they say they use the Cox proportional hazards method to estimate the hazard ratios. We saw this in the abstract. I'm not really a statistics guy, but I'm familiar enough with the Cox proportional hazards method. Let me quickly explain what that is. In biostatistics, you often are interested in the time that it takes for an event to occur and how that time is influenced by other key factors. That is known as survival analysis. For example, you're interested in the time that it takes from exposure to a certain chemical and death or cancer or some other kind of diagnosis, or for the time of relapse after a rehab program, etc. Basically, anything measuring the time it takes for something to happen. There are whole books you can read and whole courses you can take on survival analysis, but to make a long story short, is generally concerned with estimating one of two functions. The survival probability function, which is the probability of survival, i.e. the event not happening up to a certain time. The other important quantity is the hazard function. It's a bit more complicated, but it's the probability of the event happening immediately after time t, given that it does not happen until time t. If you know anything about probability, this notation will look familiar to you. The hazard can be interpreted as a sort of an instantaneous risk. What is the probability that the event will happen right now, given that it has not happened yet? These are two example curves of the hazard and survival function. Anyway, what the Cox proportional hazards method does is it estimates the ratio of the hazard functions for the survival event between two groups. For example, if you want to study some event and want to compare between males and females, so males to females, the method would tell you what the hazard ratio is and whether or not the difference is significant. For example, if the hazard ratio of males to females is greater than 1, that means there's a greater hazard for males over females for this particular event. If it's below 1, then the opposite holds true. And if it's 1, then that means the hazards are about the same. So there is no difference between the two. That's what the Cox proportional hazards method is used for in broad strokes. And that is essentially what they use in this paper. There are more details and variations that you can delve into. They talk about stratifying the data in the paper, etc. And if you read these kind of studies more, you see that this is a pretty common approach. You'll see the Cox model used all over similar studies. As always, how much further you want to investigate this depends on your interest, and I'm certainly not an expert in these types of statistics, so I'll move on. Next section talks about the sibling analysis, which is a crucial part of this paper, as we saw in the abstract in the introduction, and this is sort of what differentiates this from other similar studies. Basically, what they're doing is comparing siblings, where in one case the mother took acetaminophen and the other case she didn't. Is there a difference there? That would point out to a genetic factor being most important. And then the last part of the method section talks about a sensitivity analysis, the various tests that they perform to check the validity of their statistics and the results, which, to be frank, I'm not sure I understand entirely, but this is something that I would normally investigate at the very end after I've read and understood the main points of the study, or if I was comparing this approach with other approaches in other studies and so forth. You get the point. Next, we move on to the results section. One thing that you might notice while reading this and other papers is that there is a lot of repetition, like a lot. In the results section specifically, a significant portion of the text is spent explaining, describing, or summarizing the figures and tables that are present in the same section. So if you can go through and understand the said tables and figures, you might be able to save yourself some reading. Conversely, if you're struggling with the figures and the tables, the text might help you understand them better. In this paper, the results are pretty much summarized in Figure 3 and Table 2. Figure 3 also being a table as well. I don't know why they call it a figure. I guess because there's this thing on the side, but it's essentially a table. So these two tables pretty much summarize all the data that is presented in the results section. So let's start with Figure 3. Figure 3 shows, divided in 3 sections by the disease, the results for each medication that they test in this study. The last column, which is what we'll focus on shows the hazard ratios, as I explained before. We see that for each data points, for each medication that tests, we have a hazard ratio with and without sibling control. So what the data shows is that there is an increased hazard for taking the medication, for taking these medications in relationship to these neurodevelopmental disorders. However, the hazard ratio is reduced to 1 or below 1 when sibling analysis is added to the model. This happens pretty much across the board, with a couple of exceptions here and there. These exceptions are interesting, like anti-migraine medications, which doesn't change, although this only happens in autism and does not happen with the other two conditions they consider. Next is Table 2, which tells more or less the same story, but also contains some dosage information. Once you adjust for the confounding variables through sibling control, the dose doesn't seem to matter. I think if you understood these two figures correctly, you can just skim the text of the results section and it more or less says the same thing, explaining and clarifying certain things. You can read it if you want, or if you have more questions about what is in the tables. But I think for the purposes of this video, I think these two figures, and Figure 3 and Table 2, do a pretty good job at giving us a clear picture of what the results are and what the data tells us. The next section is the discussion section, which, as the name implies, discusses the results, any caveats, nuances, relates to the literature and stuff like that. In other words, it contextualizes the results. The results are summarized, concluding that the association between acetaminophen and these conditions are at best a non-causal one. Then they discuss several other studies and their various results, some agreeing with this paper and some not agreeing with the results of the studies, and the authors of this paper make the case that why this study is superior to those, mostly due to the gigantic sample size, but also to the use of sibling control. Of course, they also make sure they provide the limitations of their methods, for example, that the records for acetaminophen may not have included everything since over-the-counter use, and it's possible that the parents forgot to report everything, or reported lower dose than taken, or maybe higher dose, you never know. Of course, that's often a limitation in all studies of this nature, but I think generally the conclusions of this paper are pretty clear. And you have a final note on the conclusions of this paper, which are pretty short, and they essentially repeat what has been stated multiple times in this paper, that there was no association between acetaminophen and the neurological disorders that they considered in this paper. And that's essentially concludes this article, and if you've understood that much, you pretty much understood the paper. Okay, so that was it for the paper. As I said, depending on what your aims are, this can be a long or a short read, maybe more work that you have to put in or less work. It depends. So where do we go from here? Well, you can investigate the topics discussed in the paper further. You can investigate the validity of the statistics, the data collection, the conclusions, the results, the analysis, etc., usually by reading other papers like this. The first video I made in this channel, after all, was about how one paper doesn't necessarily prove or disprove anything. So having multiple papers to support whatever point or whatever research you're doing is always a plus. A good start for this is, of course, to look at the papers that are cited within this one, either in the introduction or in the discussion. It can also be good practice if you're new at this. Another thing you could do, perhaps more valuable, is to look at papers that were published since then and have cited this one, the one that we just read, of course. These could be responses, follow-up studies, replications, etc. Other papers that for one reason or another cite the paper that we're reading. This article in particular is pretty new, having just come out in 2024, so naturally the newer the paper is, the less citation it's going to receive from newer papers. Still, I'm sure there are some. So how do you find them? Normally, the journal page where the paper is will have a cited by section, where you can see which papers have cited this paper since its publications. Unfortunately, this article I just went through in the Journal of American Medical Association doesn't seem to have that, which is annoying. So we have to find it some other way. Well, a good way to do this, to find information, is to either Google the paper, like I said, and look for an alternative source where they might have information like that, or to search the title in some article database. In most cases, searching on Google Scholar should suffice. So just copy the article title and paste it in Google Scholar, then just click on the cited by link that appears once you've identified the correct article. And then you can see all the articles that have cited this paper since its publication. It's not perfect, sometimes it misses things, but generally it's a pretty good overview. Anyway, going through this collection of papers is a good way to examine the validity of the study you just read, what subsequent studies say about it, or how do they report it, how has it been received, etc. One particular paper that caught my eye was this one by a Japanese group published in the Journal of Pediatric and Perinatal Epidemiology, which shares very similar characteristics with the Swedish paper. They also have a pretty large sample size and extensive data collected on children and parents, and after a similar analysis, they reach pretty much the same conclusions. There is an increased risk when you look at the raw data, but once you include sibling control, the risk goes away. There's even an interesting piece of insight in the abstract where the author suggests that the bias on the results may be due to unrecorded over-the-counter use of acetaminophen, which makes sense if you think about it. It's reasonable to assume that some over-the-counter use of acetaminophen did not get reported, and that would artificially bias the results towards an increased risk. Anyway, at this point, you may conclude that you've read enough and maybe you'll keep an eye out for future publications on this subject, but you're done for now. Or, despite going through the paper slowly and methodically, you found that some parts still confuse you or you struggle to understand certain parts. In this case, you want to take a step back and maybe try to identify what knowledge you may be missing that would help you understand these parts better. Perhaps a short refresher in statistics or biology or chemistry or whatever, depending on the context. Something like that. You get the picture. To conclude, remember that you're doing this for fun. At least part of this process should be enjoyable. Otherwise, what's the point, right? I'm sure you have better things that you could be doing. If you're in a place where you're forced to read scientific papers, you probably made a wrong turn somewhere. Although, hey, who am I to judge? Either way, I hope you had fun watching this and you learned something.
Okay, so I have a confession to make. While I did want to make a video about how to read a paper, go through an example and all that, I also wanted to make a video specifically about this paper, about the paper that I just went through. And I wanted to be clever about it or disguise the fact or something like that just to be coy. But I guess what's the point now? So this has been in the news lately, or at least it was at the point that I'm recording this. I'm not sure when this will come out. And I just wanted to cover the topic and at least show what the cutting edge of research says on the matter. This paper and the follow-up that I mentioned seem to suggest strongly that acetaminophen, or tylenol as it is known in the States, is not really associated with autism or other neurodevelopmental disorders. Could it be wrong? Yeah, of course. All these studies are, after all, probabilistic in nature. We can say with a certain probability that it's unlikely, but we cannot outright reject it, or we cannot outright rule out the possibility, so to speak. And even if the opposite effect had been found by these studies, the same thing holds, right? It's a probabilistic effect. If I had to guess, and this is just a guess from someone who is not at all an expert in medicine, in fact, far from it, I would say that if an association was found between acetaminophen and autism, and that's a big if, I think that it would be fairly small. And it would be just one of a myriad of factors that contribute to the condition, the biggest of which I suspect would be genetics. So the real question, as I see it, again, not a medical expert, but the real question is not one of acetaminophen versus autism, but one of acetaminophen versus the alternatives. All medication is taken because the benefits outweigh the risks. No medication is ever without risk. So it would be the risk of taking acetaminophen, whatever that turns out to be, if it turns out to be anything, should be weighed against the risk of not taking it or taking an alternative if that alternative exists. Again, not an expert, I want to emphasize that, but my understanding is that fever can be pretty dangerous during a pregnancy. But again, not a doctor, or at least not that kind of doctor. And actually, the authors do touch on this point, the authors of the paper that I just went through. And I also want to make it clear that I'm not really telling anybody what to do, especially pregnant women. It's not my place, after all. In the end, these decisions are to be made between the patient and the doctor. But whatever that decision is, it makes sense that should be at least made with the most up-to-date and reliable research in mind. And for the most part, I think that is probably what's happening. That is why medical doctors, at least the good ones, always keep up with the latest research. And that's how it should be done, and I think that's how it is done most of the time. Anyway, this was the video. This is the end for True this time. And hopefully, I hope you got something out of it. Maybe some encouragement to approach the scientific literature more and bypass the middlemen, so to speak. Or at least you hopefully learned something about this topic specifically. In the end, there's no reason to believe, to the best of our knowledge, etc., that there is a link between acetaminophen and autism. Raw milk, on the other hand,